Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this particular video we will learn the second chapter of ADC 2 semester number 4 for Mumbai University EXTC branch. Although it is for EXTC branch, it is important for different branches such as electrical, instrumentation, computers and so on. So we are learning multi-stage amplifier, and in this particular video we will learn the types of coupling in the multi-stage amplifier. So far we have discussed the multi-stage amplifier concept, that is nothing but the improvement in the gain, improvement in the input impedance, output impedance and so far. So we will learn the three categories of the coupling of multi-stage amplifier. So what do you mean by the term as coupling? So coupling means in which way I will connect the output of first stage to the input of second stage, output of second stage to the input of third stage and so on. So there are different ways with which we will connect it, output of first stage to input of second stage and so on. Okay. So there are different techniques we will be using, that are nothing but first is RC coupling, second is transformer coupling, and third one is direct coupling. First one is RC coupling, second one is transformer coupling and third one is direct coupling. So if we are looking in this particular types, we'll get to know that if we are taking RC coupling, that means resistance, through resistance and capacitors we will join the output of first stage to input of second stage and so on. In the transformer coupling, we will make use of the transformer to join the output of first stage to input of second stage. And in the direct coupling, obviously the word direct tells you that the output of first stage directly connected to the input of second stage and so on. So we will learn one by one with the RC coupling, transformer coupling and direct coupling in the different way. So first is RC coupling. So I will draw the diagram, then we will get to know that how it is getting connected. Even though R and C is being used, but the connection orientation will be different. Take the live example of using, let's say, BJT as an amplifier, the first stage. This is input coupled. So input is coupled with the capacitor and these two shunt resistances, that is nothing but R1 and R2. This is RC and this is RE. Okay. Now here we will be getting the another capacitor, that is CC2, which will act as a coupling between first stage and the second stage. So here we will say that this is the second stage I am trying to draw. I can say that this is resistance R1 and this is resistance R2, or this is R3 and R4 I can say, as it is combining with R1 and R2, RE2 I can say, here RE1, RC1. You can have different DC level, this will be VCC2, this will be VCC1, okay, and again here connect the output with coupling capacitor CC3, right. Here I can have the flexibility to use CE1, that is bypass capacitor 1 and bypass capacitor 2, depending on the situation, depending on the requirement of the gain from the customer side, we will design. So here what is different thing that we have to learn? Coupling is using these two connections. This capacitor is basically not directly connected to the input of the next stage. Rather, this capacitor along with the shunt resistance R3 and R4, right, this connection is giving the kind of coupling that is called as RC coupling. Okay, so in RC coupling I can say C in series and R in shunt. So you can have any configuration, any biasing types. Here I have drawn voltage divider, more sophisticated type voltage divider, because it gives more stability than that of different biasing techniques. So R3, R4 and CC2, R3 parallel R4 connection in shunt and CC2 in series, that forms the coupling between first stage and second stage. So here I can say that this is your first stage and this is your second stage. In this particular semester we will just have to learn two-stage amplifier, but it is possible to have multiple stage or multi-stage amplifier having 10 stages, 5 stages, 4 stages. But as we learn more and more stages, what will happen? Your bandwidth will reduce and reduces, and your gain will increase and increases. So we have to compensate with your gain as well as bandwidth. So depending on the customer requirement, we'll have to get that particular amount, that particular stages ka multi-stage amplifier. So in this particular RC coupling, what are the advantages that we'll be getting? So advantages, we'll write in the blue form. Advantage, it's a very simple. We'll get very simple, and this basically more advantage, most used this RC coupling. This is because we isolate two stages by using in the DC analysis phenomena. So CC2 is getting opened in DC, right? So basically first stage and second stage getting isolated by using this capacitor and resistance network, that is RC coupling. Okay, few more advantages we have. It is of cheap, so cost effective I can say, right? It is more cost effective. It will require less space as far as fabrication is concerned. So this is very important as far as manufacturing is concerned. Less space and weight. And fourth important is, it is mostly used in audio frequency range. So used in AF range. The frequency response which we will be getting is excellent in AF range. So we'll have to learn what are the disadvantages that we'll be getting in this particular RC coupling. So disadvantages. The disadvantages, that is, it has not been used for impedance matching networks. For example, if we want to connect two circuits having different impedance, for example, input impedance and output impedance of first circuit, I want to connect first circuit into second circuit, and output impedance of first circuit is not matching with the second circuit ka input impedance that I am going to connect with the output of first. Then what will happen? We'll have to connect the another circuit which will match two impedances, right? So basically this is not even used for impedance matching, right? So impedance matching is not good for this particular RC coupling circuit. So not good for impedance matching. Whatever voltage and power gain that we'll be getting, that is low as compared to other two techniques. It's been used in AF range, we get significant gain, but if we want more than that particular value of gain, then it has not been useful. Okay, so this, due to RC network, we will be getting the noise, right? So some noise will be there in the RC coupling. So if you take any kind of circuit, noise has to be there. Noise is like a tension. You cannot reduce the tension. You cannot completely destroy the tension. Same as that of tension, the noise has to be there in the circuit, but we can reduce that noise, but we cannot destroy that noise. As compared to other two networks, other two types of coupling, here we will be getting the large noise. So okay. So far we have discussed advantages if are dominating over disadvantages, then we will be using this RC coupling as far as obviously customer requirement is concerned. Then we will learn the other second type of coupling, that is nothing but this transformer type of coupling. We will learn that. This is a simple RC network. Is it simple RC network? No, it's not RC network. It's amplifier, and I will not be using this is not being used, and will cut this part, and this is the at the output stage we will be using the transformer. So at the output stage we will not be using the resistance at the output, we will be using the transformer. So this is VCC1 and this is your input transformer, and first of all we will draw the this transformer is connected to the input, that is base, right, and this through this resistance I will be getting the voltage, that is plus VCC2, right. So transformer ka secondary is connected to the junction of R2 and R1, R3 and R4 rather. This is R3, this is R4, this is RC2, this is RE2. We will do all the Namakaran. RE1, this is R2, this is R1, right. Now in this case again we will not be using RC2, we will use the coupling in the form of transformer, right. Similarly, we will be getting the output at the secondary of second stage ka transformer, right. So this is transformer 1, right, and this is transformer 2. Here what we are dealing, we will get the excellent input impedance matching. Cut this part. We will be getting excellent impedance matching. Okay, so that is nothing but your biggest advantage as far as transformer coupling is concerned. So we will say that this is your first stage. This is the part which we are dealing, how it is getting connected to the input of second stage. Okay, so this is your transformer coupling, and this is your usual second stage. As I have connected the transformer at the second stage, this will be your output that will be getting, and more or less this output also can be connected to the input of the third stage and so on. So here this is the fundamental of your transformer coupling. As far as advantages and disadvantages are concerned, we will just learn few points. Advantages: first is, as I told you, excellent impedance input impedance matching. Sorry, it's not input impedance, excellent impedance matching. Imp matching. Second is, we will be getting no loss of signal in the DC power. Okay, in the terms of DC. So signal power, which is nothing but VCC1 and VCC2, that will not get lost so much. So no loss of signal as far as DC power is concerned. Obviously, third very important as far as customer requirement is concerned, we will be getting high gain as compared to your RC coupling. So we will be getting high gain. Now we'll have to look at the disadvantages. So we'll learn, as whenever you see the transformer, it becomes bulky, right? So it becomes a bulky in nature. Secondly, costly, require more space. Okay. Third one is there are high frequency distortion. So which is not at all desirable. So we want the frequency distortion should be very less, right? What exactly the frequency distortion? This term we will learn in your power amplifiers, that is chapter number 4, okay, in detail. So frequency distortion, by the time just learn in that way, we will get the smoother output. For example, in your TV, we suppose we are getting all the ants, like, the structure is not clear in your display of your TV. Then in previous cases, what we used to do, we just change the orientation of the antenna, and then suddenly we get the particular picture. So it matches with that particular frequency. So if we change the frequency, we will not get that particular output. So the frequency distortion is there in the transformer coupling. So we will not usually use the transformer coupling. So these are the advantages, these are the disadvantages. So generally we are not using the transformer coupling. As far as the syllabus is concerned, we'll just use the RC coupling, either RC coupling or direct coupling. They may ask you the question about the direct coupling as well. There are few examples, dedicated examples, which we'll learn as an RC coupling, and few dedicated examples that we'll use as an complete direct coupling. So we'll learn the third part, that is third type of coupling, that is third is direct coupling. Now in this direct coupling, it's very easy to understand that my first stage does not require any capacitor or any resistor or any other transformer to connect the output towards the second stage ka input. Okay, so this is directly connected to the input of second stage. It can be your voltage divider bias, it can be your self bias, it can be a fixed bias, any. But here generally we use voltage divider bias, obviously for the stability perspective. So here we'll get the output and here we'll get the input. If you want the source input source resistance, then we can connect the source resistance as well. This will be R1, we'll do all Namakaran. So this is RC1, this is RE1, this is R3, this is R4, this is RC2, this is RE2. So it's a very simple circuit, I can say. Now this is nothing but one of the disadvantage, I can say. It's a simple circuit. So obviously cost effective as well. So let's learn directly. This is nothing but your first stage. This is nothing but your second stage. And I can say that this is your direct coupling. Okay. So let's learn again the advantages and disadvantages perspective. Advantages. It's a simple circuit. Second is also cost effective. Okay. Here also we will get good frequency response and good impedance matching as well. So there are two advantages simultaneously. We will be getting good frequency response, and the fourth one is good impedance matching. But as I said, advantages are there, disadvantages or limitations has to be there. So we will say disadvantages. For the direct coupling, disadvantage first is for high frequency I cannot amplify with that much value as compared to RC and transformer coupled. So at high frequency amplification can't be achieved. Okay, efficiency is less. What is efficiency? Whatever we are getting the output, right, and what I am giving as input. So if we take the ratio of output to input, that is nothing but your efficiency. That efficiency part in detail we will be taking in a technical sense in the chapter number 4, that is power amplifier also. So stay tuned for that. Efficiency is very less, and the major reason of this less efficiency is we will be getting the DC loss because nothing has been connected to the input of first stage and output of second stage. So I can say that current of first stage can enter into the second stage. So I can say the DC power loss is the main reason, main cause for the less efficiency, DC power loss. Okay. Now the third disadvantage that we'll be getting is drift, right? So drift in the DC amplifier will result the poor Q point stability. So we will say that poor Q point stability. This poor Q point stability will lead to have not fixed reference point for my amplification perspective. So sometimes you get clipped off output voltage, sometimes you may get the distorted output voltage, and that's how we not to use generally the direct coupling in your circuitry and a practical sense of the multistage amplifier. But although these factors, will be using this particular direct coupling in two kind of transformer, that is nothing but Darlington pair amplifier and your cascode amplifier. Okay, so stay tuned for that. We will learn more and more EDC 2 chapter number 2 for multistage amplifier analysis as well as design. So learn more and more EDC 2. In this particular videos we have studied RC coupling, transformer coupling and direct coupling. So we will stop here. In the next videos we will learn the multistage amplifier in the design as well as analysis mathematical perspective. So thank you very much for watching this particular video. Learn Ekeeda, learn EDC 2 from Ekeeda videos and be happy. Thank you so much.